What's up, guys? We're back. It's been a while, been a long time. Coming back with something big. Coming back with the rock cycle. Rewind, we're coming back with the choc cycle. I got my guy DB over here, he's helping me out. So we've done some book work, it looks like that. That's just some standard stuff, you've seen that before, it's in all your books, you got it. We're gonna take it to another level. We're gonna go choc cycle. Yes, right, you heard me right. Choc cycle, not rock cycle. You see what I did there, it was smart. So we're going to have the chocolate. I'm not branded. This is not paid promotion here. But Hershey's, you want to sort me out, you come find me. Okay, so we got the Hershey's chocolate. The important thing is white chocolate with some big cookie bits in it. So we got the cookies and cream. So we got the chocolate and we got the cookie bit. We got ourselves some bubbly chocolate, the Aero Mint. It's green. It's going to look cool and it's bubbly. That might be useful later on. And then we got your good old classic, your classic Galaxy. Not saying anything more than that, but if you want to start, if Galaxy Chocolate, Nestle probably, if you want to get in touch, we'll make it happen. Okay, so I got my 3 types of chocolate. So I got my 3 chocs. So let's swap that back out and let's make sure that these are 3 rocks. So imagine these are 3 rocks instead of 3 chocs, but in fact they're actually 3 chocs. So these are going to be my igneous rocks. Okay, so we need to make sure, now we know that rocks are solid. There we go. That's a nice bit of galaxy there. That's a nice big piece of igneous rock. Oh, look at that. Beauty. And then we're going to go for another type of igneous rock. This one is bubbly though, which might be how it cooled down so quickly. Remember this stuff, where's this stuff come from? Volcanoes. Okay, it comes from underground, comes from magma cooling, or it comes from lava cooling. And if it cools really quickly, you might even get these amazing things in here, like this is Aero chocolate, but I'm thinking pumice now, the rock pumice, the choc Aero. You see how I've done that? I've done that smart. So I've got another rock there, my last rock there, my last piece of igneous rock for this experiment here. It's a delicious one here. Now obviously we don't eat anything in science, so I couldn't eat that, especially not now it's hit the deck. But I could borrow this. Now this might be similar to something like, I don't know, granite maybe, with big crystals inside. All right, so there's a nice big granite. So I got the granite, I got the pumice, I got some other igneous. So I got my 3 rocks, I got my 3 chocs. Igneous from volcanoes, from lava. Now over time, and we're talking about the history of Earth, 4.8 billion years, over time some of these rocks might get broken up a little bit, might get chipped away. Some of them might get broken into smaller pieces. The weathering, the oceans, the rivers. There's lots of reasons why these might get broken down into smaller pieces. For our model, we're going to break them into really small pieces. Those small pieces are called sediment. We're probably going to go fast mode on this. We're probably going to go twice speed on this one. So don't worry, I'll stop speaking. We're going to go like fast, and there'll be loads of little sediments. Here we go. Nice. So that is the choc cycle. I've just created up loads of chocolate. In real life, you would have sediment created by weathering, erosion, chemical corrosion as well. You've got lots of other possible ways that rocks get broken up in a natural way. Then what happens is this rock, this sediment will travel, will get moved. It may get moved by the wind, may get moved by water, lakes, rivers, the ocean, but when it sort of slows down, it will be deposited. Okay, so deposition is to drop down, to fall, to the bottom of the ocean or wherever it is. So we got deposition. Now, if this keeps happening over many millions of years, there's going to be more and more layers, and so there's going to be more and more pressure. Pressure is the push. All right, so it's reasonable to think that over lots and lots of years, this happens, and we end up with something called compaction, where we get layers and layers and layers and layers over time. That's why I've chosen a different colour chocolate. Now you're starting to see it. And over time, you will get something called compaction and cementation. Okay, so imagine I'm doing this over many, many years. And there's a reason why sedimentary rock, if you look at it under a microscope, is made of small pieces, and you can usually see the small pieces. Sometimes they're round pieces, like in sandstone, but usually you can see the layers of them, the layers of the sediment, and over many years compacted and compacted and compacted. Remember, they started off as big solid objects, big solid pieces of chocolate. Then they went to become tiny pieces of chocolate. And now we're getting big pieces of chocolate again. So sedimentary rock under a microscope will look like this. Small pieces squeezed together, but you can see the individual types and the individual layers. Maybe I'll pick this up. Here you go. Okay, so that's an example of sedimentary rock. So you see the layers. You see how it's been squished together to form a new solid object, a new rock. Big piece from small pieces. All right, so that is your igneous rock to form sedimentary rock. Now here's the cool part. Going back to my guy, this book, we've got another type of rock. We've got metamorphic rock. Now metamorphic rock is when this sedimentary rock becomes pressurized, squeezed, lots and lots of heat and lots of pressure. The sedimentary rock is quite crumbly, you can see that. Sedimentary rock, as you can see, can become sediment again quite easily. Okay, so we're putting it in the bag. I'm just going to give it a little bit more of a compaction, cementation. I'm going to give it a bit of a squeeze. Try and get it back into sort of a rock sort of shape. Okay, so now we've got sedimentary rock. I want metamorphic though, so we're going to heat it up. Water bath.
So you can see this is starting to melt immediately. And as they start to melt a little bit, they're going to start to come together. Some of that nice milk chocolate, some of that white chocolate, some of that green chocolate. It's going to start to sort of melt a little bit close to each other. Oh, look at that, it's looking good now. That's exactly
what we want. Now, a good example of a metamorphic rock, which is a sedimentary rock that has been squeezed and heated and squeezed and heated and start to change. Nice example of that is marble. And how would you describe this chocolate? Marbled. Okay, so we're going to start to see that they sort of start to come. Oh, that's a beauty, look at that. Lovely stuff. Okay, now for the sake of this video we're going to speed up the cooling process, so we're going to cool it down. Now this has not got started again, this has not become igneous, it's just been cooled down. So let's just cool that down a bit. Ice water. Now we know from our normal science that melting can be a physical change. If we cool it down, it should solidify or freeze. Now chocolate is a good example of that happening. Just going to put a little Easter egg in there for my guys that my true believers. Yeah, I think it's worked. So I think we have got ourselves a metamorphic rock here. I think we've got marbled rock. That was a sedimentary rock that experienced lots and lots of heat and lots of pressure, and so it changed how it looks, changed some of the properties through heat and pressure. So remember, solid objects hold their shape, and look at the marble texture there. Still a bit warm. Ooh. Still a bit like. So that you got yourself there is a metamorphic rock. Now that could become sedimentary again if we bridge it up, but we won't because we're too proud. So what's the final part of the puzzle? This can become igneous again. If the tectonic plates move, or this rock ends up with more heat, more pressure, more heat, more pressure, more heat, more pressure, it can become igneous again. It completely starts the cycle once more. Cool this down for the model. So remember what we started with. We had started 3 different types of igneous rock. We had the sediment, we had the sedimentation, we had the cementation, we had compaction through chemical weathering, through physical weathering. We had the sedimentary, then we squeezed it and pressed it and we got sedimentary rock, and then we heated that up and we got metamorphic rock, and it had that nice marble texture. And now we've just started again completely because we've melted down our metamorphic rock. Remember what we started with, these 3 here, and we're going to end up with a complete reboot, starting again with a new rock, a new igneous rock, but it contains all of the minerals and the compounds and the chemical structure as before, but the physical structure has changed. So there you go, my guys. That is your choc cycle to help understand the rock cycle. I'll put a nice little image of a rock cycle here in post, and hopefully that helps us understand the key ideas. Igneous goes to sedimentary by breaking down chemical weathering, physical weathering, abrasion, deposition, compaction, cementation. Heat that up, heat and pressure, heat and pressure, heat and pressure, get your metamorphic. Your metamorphic rock is that nice sort of marbly structure that you saw before. Then if that keeps getting heated and keeps getting pressurized, and heats and pressure is going to melt completely, it's going to start again, you're going to get yourself a new igneous rock. However, metamorphic can become sedimentary. Igneous can become sedimentary. Sedimentary can become sedimentary. It's a cycle. It doesn't have a start, doesn't have a beginning, doesn't have an end. It just keeps going and 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 keeps going. Bye.